I'm going to have a look at just an overview of statistics and collecting data and the whole process. And just in general, first thing we normally do is we pose a question, then we'll try and collect some data, then we'll try and present the data and analyse it. They're very much linked, presenting and analysing. It is all linked. And finally, once we analyse the data, we might interpret the results and try and figure out what is the data telling us in relation to the question that we posed. Or sometimes we might realise that when we analyse the data, that maybe the question that we asked at the start was phrased badly, or maybe it's not actually generating the data that we really wanted to find out about. So we might have to change the question or change the way the question is worded, or remove any bias that might have been leading in the question and then go again. So it doesn't mean that I go through the process just once and I'm finished. I could get to the end and slightly go back, slightly change the question, start and go through it all again, and potentially again until I've refined the method enough that I'm actually collecting the data that I want. Whether it doesn't matter what way the data is coming out, whether it's the way I anticipated or not, I'm getting the data that I actually want. So first thing that we pose a question, it's clear and concise. It's in no way biased or leading. It can't be along the lines of, this is a nice chocolate bar, isn't it? You're going to have to be as non-leading as possible. You might try and anticipate the type of data that you might get when you ask a question. Is it going to be numerical? Is it going to be categorical? If it is numerical, is it discrete or is it continuous? If it is categorical, is it nominal or ordinal? And when we have the question or questions posed and we're happy, it's you might get other people's opinion on the questionnaire, etc. But you move on to your second phase. So we said no bias there, not leading questions, the questions are clear. So then when we go to collect the data, you're trying to figure out, do I want to survey the whole population? And that doesn't mean everybody in the world. That means everybody in if I just give an example, maybe that I want to survey everybody in Munster that plays hurling for their club. That would be an example of a full population. It's not everybody in Ireland or everybody in Munster. It's just a category of people that I would like their opinion from, or their views from, or their data. So I could survey the whole population, or I could survey a sample of the population. This is far more likely to survey the sample. And then the next thing, if I decide that I'm going to survey a sample, well, how am I going to do that? And how am I going to select it? And what size do I expect? What time frame do I have? What resources do I have in order to survey the sample? Because that might actually impact on the size that I choose or how I go about surveying. If I do collect data from a sample, well, usually, if I surveyed a sample of people, like I had given the population was the people in Munster, anyone in Munster that plays hurling for their club team. Well, maybe I survey one person from every club that's a hurler. And, I randomly select a person from each club. And if I find out that 90% of them are happy with the facilities of their own club, that I call a statistic. It's a bit of information or data that I've collected on the sample. But like that, if I happened to be able to survey everybody in Munster that plays hurling for their club, that would be the population. And maybe I find out that the whole population, out of everyone I surveyed, 85% of the population are actually happy with the facilities in their club. Well, that we would call a parameter. So then I often ask the question, well, why is the topic that we're studying called statistics instead of parameters? And if you have a think about that, well, really, the reason is that we never really survey the whole population. Most of the time, we survey the sample of a population and we get a statistic, and we talk about a statistic because we don't talk about parameters, because it's unlikely that we'll survey the whole population. If possible, we would, but time constraints, resources, etc., doesn't mean that I'll always be able, or it's even possible to survey the whole population. And so if the majority of the time it is a statistic that we get from a sample, then how do I select the sample, the people in the sample? And you can randomly do it. Random would be best, pick names out of a hat. Or obviously a computer could do it. It doesn't have to be names out of a hat. There's faster ways to do it than that. It could be, you could do it systematically. You could split your sample into subcategories, and you could survey 50 people from each category randomly. That would be kind of more stratified and types of sampling, and there's loads more ways to do it. Some ways are not randomly sampled. Sometimes it's just convenience that we do it with. And all these questions should probably be asked if someone gives you a statistic. If they tell you, oh, I collected this information, I gathered this data, one of the main questions you should be asking them is, well, how did you collect the information? Who did you collect it from? Was it the population of the sample? How did you decide who was in the sample? Did you decide how many was in the sample, etc.? And when you're happy with how you've collected the data, you're looking at presenting the data. So you have your bar charts, your pie charts, stem and leaf. So stem and leaf is purely for discrete numerical data. Histogram works well for continuous numerical data. You could do a scatter graph, and a scatter graph is where you're going to compare two pieces of numerical data from a certain person or a source. I'm going to do a video on scatter graphs so you can see that, or I'm sure if you look on YouTube you'll easily come across examples of a scatter graph and how to draw them. So how you present the data, well, there's loads of ways of that, and you have to choose it so that it's easy for the people that are looking at your graphs to actually see the information. A picture represents 1,000 words, or a picture says 1,000 words. That's the idea that you're looking for, that it's clear and actually represents the data that you've collected in a concise way. And then you're going to look at analysing the data. You might look at measures of centre. That's your mean, your mode, and your median. So for let's say categorical data. Can you get the mean of categorical data? No. Can you get the mode of categorical data? Yes. And can you get the median of categorical data? No. So the only option if you've categorical data is the mode. And let's look at numerical data. If you have numerical data, can you get the mean? Yes. Well, the mean is actually the best one usually. You'll have to look at examples of this to actually see. So this is just an overview in this video. So the mean is usually the best one, except if you have outliers. Outliers will actually pull the mean in the direction of the outliers, like it'll skew the data that you get or skew the statistic that you get. Can you get the mode? Yes, but it requires very little calculations. It's very easy to get. And can you get the median? Yes. So when it comes to numerical data, you have all three as options. The median I would use if there are outliers. So the outliers, if you use the mean, are going to skew the mean in a direction where the outliers are. So the median will be better in that situation if you do have outliers. So if you have categorical data and you decide to give a statistic on that, maybe 10% of the population like this chocolate bar, we actually call that P, the percentage or the proportion of the population. Maybe you only surveyed a sample and you found 12% of the sample like this chocolate bar. We actually call that P hat because it's the percentage or the proportion of the sample that maybe like the chocolate bar. Maybe if you had numerical data, we'd usually use the mean. If you gathered information from the population and you got the mean of the population and you found out maybe the average use, or the average time that people spend on their phones per week is 5 hours, that we call mu if you've surveyed the whole population. However, if you only took a sample and surveyed that and got the mean of that, we call that X bar. So those little symbols are important because they mean, is it a proportion of the sample, or is the proportion of the population? Is it the mean of the sample, or is it the mean of the population? You also could look at measures of variation, not just measures of centre. So we have, when you're analysing the data, you could talk about the range, the interquartile range, standard deviation. And it's also possible that when you're analysing the data that you look at the measures of relative standing. So two of the measures of relative standing that we look at are percentiles and Z-scores. So we'll keep all those things in mind when we're actually analysing the data. And then we'll try and interpret the results and see, well, maybe things that we thought we would get from the data, we found out, oh no, people don't actually think that. So we interpret the results. And if I need to, I'll go back to the start and maybe change the question or pose a slightly different question.